In this lesson, we're going to take a look at experiments and observational studies. Within that, we're going to talk about confounding variables, causation and association, observational studies, and experiments, and a special type of experiment called randomized experiments. So, look at this, answer the question, a quick review from the last lesson. In here, we cannot say that it was a valid one because, or the results could be trusted because it was a voluntary sample. It was emailed out to people, and then you had data that came back from some people that chose to respond. So once again, we have our population. We take this sample out of our population, hoping our sample is representative of the population. And we get data from that sample to make conclusions about it. And that's our focus today, is getting that data from that sample. Two variables are associated if one variable tends to be related to another variable. Two variables are causally associated if changing one of the variables, the explanatory variable, influences the outcome of the response variable. So, take a look at these situations here. Try to identify an explanatory and a response, and a causal association or not. So pause the video and do this. So, on the first one here, our explanatory variable would be daily exercise, and our response variable would be the mental performance. And we're trying to get at a causal association, as in daily exercise or not, or how much exercise influences the mental performance of people or of animals or whatever it is you're measuring. The next one down here, we have weight loss and we have fiber. We're hoping that eating more fiber, which is our explanatory, will allow us to lose more weight, which would be response. We are also hoping for a causal association, as in eating more fiber allows us to lose more weight. On the bottom one, it's not really an explanatory response situation, and it's definitely not a causal association. It's just an observation that cat owners tend to be more educated than dog owners. So association does not mean one causes the other. Two variables can be associated but not causing each other. So let's take a look at the following situations. So are you convinced that college education slows the brain's aging? You might be convinced from this, but it's quite possible that people that go to college are quite different than people that don't go to college to begin with. So we cannot make that conclusion. So here, you can see that on the horizontal axis going across the bottom, we have TVs per 1,000 people. We also have life expectancy going up the vertical axis. And you can definitely see as you kind of go to the right and get more and more TVs that you tend to live longer. So should you buy more TVs if you want to live longer? No. Yes, there's an association here, but having more TVs does not cause you to actually live more. There is a confounding variable involved in this situation. In the last situation we were just talking about, it would be wealth or money. So sometimes when we're looking at an explanatory and response situation, there's another variable that's influencing the results that weren't really part of the study, and that's called a confounding variable. Confounding variables can often be plausible an explanation of why there's an association between our explanatory and response. When confounding variables are present or may be present, a causation cannot be determined. So we want to go ahead and find a straight connection between the explanatory and response. But often there's a confounding variable that's influencing the situation. And so instead of going straight across, we kind of take a detour through this confounding variable. So can we actually make a conclusion about a response compared to the original? Often not. So as we look at this one here that we were looking at before, the confounding variable was wealth, which means we cannot make a conclusion that life expectancy increases as you buy more TV. So think about what the confounding variables might be for these here. So pause the video and try to work these out. Well, for the first one, I would say as ice cream sales increase, more deaths by drowning also increase. Yes. The confounding variable, outside temperature or summer. More people have ice cream in the summer, more people are swimming in the summer, so there's more drowning deaths. Confounding variable for number 2 would be the wealth of the people. If you are able to own a yacht, you probably have a lot of money. If you have a lot of money, you're more likely able to buy a sports car. Number 3, your population density. Where you have a lot of people living, you have more air pollution, you have more paved streets, you think of a big city, you have that versus out in a farm field. The confounding variable for number 4 would be our gender. Typically guys have shorter hair and typically guys are taller. An experiment versus an observational study. Observational study, you're just going ahead and you're trying to just collect information on what you are seeing and observing, hence observational. You are not trying to influence the results. You're just collecting data on what you are seeing or observing. An experiment, you're trying to actually control some of those confounding variables so that you can say that your explanatory variable is influencing the results. So confounding variables are almost always present in observational studies. So we can never use an observational study to establish causation. Hint, hint. So here we have the Greek debt and the number of people actively using Facebook. Graphs are very similar, but does one affect the other? Does one cause the other? No. Are they kind of related to each other in the way they look? Yes, but one does not cause the other. Here we're looking at funding for the National Science Foundation, and we're looking at the average global temperature. So does increasing our funding for the National Science Foundation increase our average global temperature? No. Is there an association here? Yes, but it's not one causing the other. Same idea here. One does not cause the other. And here we're looking at murder rates in New York State. And the murder rates is not caused by the mountain range, or the murder rates don't cause the mountain range. Are they somewhat similar? Yes, but it's not a cause and effect situation. So Thinking that two things are a cause and effect situation is a very common error that a lot of people will make. So, what do we have to do to try to determine causation? Well, we need to then avoid confounding variables by randomly assigning values of the explanatory variable. In other words, we want to try to do an experiment. In a randomized experiment, the explanatory variable is randomly determined before the response variable is measured. The different levels of the explanatory variable are known as treatments. Randomly dividing it into groups and randomly assigning the different treatments of each group. The treatments are randomly assigned to the randomly assigned treatment groups. We should get good results.